Welcome back. In this video, we will learn how Postorder Traversal algorithm works in binary tree. Here is our binary tree we have used before in our previous videos. The reason we are learning traversal algorithm is to ensure that all the nodes in a binary tree should be visited and each node should be visited only once. This is our Postorder Traversal algorithm. This is a recursive algorithm written here. It asks you to move to the root of the left subtree as long as possible, starting from the root. That means you start from here and you move towards the leftmost path as long as you can move. When there will be no way to move towards the leftmost path, you move to the root of the right subtree. And there, if you find another leftmost path down from this length, then you continue as in step 1. In a certain situation, you will find that there will be no way to move towards the leftmost path as well as towards the rightmost path. Then you process the node. So this is post order. That means you complete the leftmost path first, then you complete the rightmost path, then when there will be no other way to move towards the left or right, then you process the node. So processing the node is coming in the last. Here is the rule set we will follow. PTR may be null, may not be null. If PTR is not null, then you do these 3 jobs. And if PTR is null, then you do this job popping from the stack, and then you check whether the popped item is with a plus sign or with a minus sign. If the popped item is with a plus sign, do this job, otherwise do this job. So let us see how it works. Now PTR is at A, that is the root. You are asked to move to the root of the left subtree. So left subtree is this. So you move to this node B. Now this B has 2 identities. It is a left child of A as well as it is the root of the left subtree with respect to A. Now a few settings before starting of the algorithm. Top is initialized to -1. Increase top and push null at the 0th index. There will be an indication that if null comes out of the stack during the pop operation, we will know that the whole traversal algorithm is over. Now we have PTR at root, that is A. So rule 1 works. PTR is not null. What you should do? The first job, push the current node into the stack with a plus sign. Current node is A. Put it inside like this, A plus. Number B, push the right child, if any, into the stack with a minus. This is optional. If you have right child, then you will also push that right child with a minus sign. Yes, we have C as a right child. So, increment top and put C minus. The reason for pluses and minuses is that seeing the plus sign, we will know that this is the current node or the left child. And seeing the minus sign, we will know that this is a right child of some node. Then we finish the job C, proceed down the left edge. PTR comes down to B. Now again you check. Yes, PTR is not null. It is standing at B. So the rule number 1 fires. Push the current node into the stack with a plus. That means B plus will be here. Push the right child, if any, into the stack with a minus. Right child is E, so E minus goes in and then proceed down the left edge. PTR comes to D. Again PTR is not null, so D plus will be inside the stack. F minus will be inside the stack and PTR proceeds down the left edge and it becomes null now. Now we go to rule 2. PTR is null. What we should do? Pop from the stack. Now what is there on the top of the stack? F minus. So F minus will come out of the stack. Top goes down to 5 and then we check whether the popped item is with a plus sign or with a minus sign. We see that it is with minus sign, right? So what you should do? Set PTR to that item ignoring the minus. So PTR is null now. It will be set to F. Now we check again. PTR is not null. So rule 1 fires. push the current node into the stack with a plus. That means F plus will be there inside the stack. Next, push the right child, if any, into the stack with a minus. There is no right child from F, so we ignore this. We move to step C, proceed down the left edge, so PTR goes to null. Now if PTR is null, what we should do? Pop from the stack. So F plus comes out. Top goes to 5. We check, popped item is with a plus sign. So we process it and then we will pop again. So our processing is printing the data. So we process F and we go for popping again. So D plus comes out next. We say popped item is with a plus sign. Process it. And pop item again. Now this popped item is with a minus sign. So we move to this step where it is asked to set PTR to that item ignoring the minus. So PTR is null now. It will be set to E. We check whether PTR is null or not. PTR is not null. So we move back to rule 1. Push the current node with a plus sign. There is no right child. So we skip the step 1B. We move to 1C. Proceed down the left edge. PTR again becomes null. So we move to rule 2. Pop from the stack. E plus comes out. Popped item is with a plus sign. So process it and again pop item from the stack. So E is printed and again popping operation has been done so that B plus comes out now. We process it and we go for popping again. C minus comes out now. So we set PTR to C and check whether the PTR is null or not. PTR is not null. So C is stored inside the stack with a plus sign. There is right child. So right child I will also be stored inside the stack with a minus sign. Next, PTR will proceed down the left edge so that PTR will be at G now. PTR is not null, so push G into the stack with a plus sign. Right child is there, so push H minus inside stack and move PTR down the left edge. PTR becomes null now, so we consider rule 2. It says pop from the stack. H minus comes out of the stack. We set PTR to H. We check whether PTR is null or not. It is not null. So we move to rule 1. Push the current node into the stack with a plus sign. So H plus is stored inside the stack. There is no right child. So we skip the rule 1B and we follow 1C. Proceed down the left edge. PTR becomes null again. We consider rule 2 now. Pop from the stack. H plus will come out and will be processed. And again popping will be done. That time G plus will be popped. It will be processed and again popping will be done. This time I minus comes out. So we move to this rule, set PTR to that item. That means PTR will be set to I now. PTR is not null, so you move to rule 1, push current node into the stack with a plus sign. So I plus will be stored inside the stack. There is no right child. We move PTR down the left edge and PTR becomes null. We move to rule 2, pop from the stack. I plus comes out and processed. Again we pop item from the stack so that C plus comes out and processed. Again we go for popping. A plus comes out and processed. We go for popping again. Null comes out. This signifies that our post-order traversal is over. This is the way how a post-order traversal algorithm works. In the next video, we will see C coding for implementation of post-order traversal in binary tree. Thanks for watching and take care.